Hey YouTube, I'm Sergeant Indy. Welcome back to my turn-based strategy tutorial for GameMaker Studio. In this video, we'll be adding a couple example terrain features, as well as implementing an easy way for us to place objects directly into the room, and then build our grid of nodes right on top of it. Let's begin with a couple of sprites, so pop that open, create sprite. The first we're going to create is going to be called S-Wall. Edit sprite, default size is fine, let's just get in there. And I'm going to select the left click to be a black, and we want the right click to be a really dark gray. And select the square, and the second option for the square, and we're just going to go completely corner to corner, just like that. Alright, now, we could just make that whole thing black, or just the whole thing dark gray, but I think the gray and the black border will show the grid lines well, so we'll stick with that. Let's green check all the way out, that's all fine, and now we're going to make another one. We're going to call this one S-Rubble. Edit sprite. Default size is fine again. Get in here. Let's make our left click a white. We're going to do corner to corner just like that. And now let's grab the pencil tool, top left, and we're going to draw some rubble. Now, I'm not really great at pixel art, but where we're going here is just something like rubble, just rocks on the ground or whatever. So, not that hard. I'm just going to draw sort of a it's a rock like that. And I'm going to get a little fancy. Let's do another rock like this one, kind of in front of the other one. I'll put a little something here. Oh, that one's really ugly. A little something up there. Really not that big a deal. I'm going to go ahead and erase that, though. Okay, let's hit our full fill tool. We'll just grab kind of a soft gray. Fill them all up. You want to be real fancy, take a slightly darker gray, not ray. And we'll sort of just give it some shadow or something. Again, I'm terrible at this. I'm just god-awful. People who are good at pixel art, they are truly blessed. You give me a pencil and have me sketch something, I'm pretty good, but some of pixel arts, I'm just god-awful at it. Okay, so something like that. Doesn't need to be too fancy. Green check out of here. And there. No problem. All done. So, what that rubble is going to do eventually is act as difficult terrain. Something a character can move through, but it takes more effort and costs them more movement. What the wall is going to do is block movement entirely. You can't go through it, you have to go around it. So in order for all of this to happen, we need to open up our node object and add a few more variables so it can do all of that. Now, the first thing we're going to do is we're finally going to let these nodes know where they are in the world. This is sort of important in the long run, but it wasn't really necessary for anything we were doing at the time, so I put it off until now. But it is important. So grid X, you guys know this song and dance, equals 0. Grid Y equals 0. And now we're going to add a couple more variables that relate to terrain. First, each node will have a type to denote what kind of terrain that they are. So type equals node, and node will just stand for a basic open square. Obviously, we'll have other types later. Now let's add a new one. Cost equals 1. Cost will be how much movement it costs to go through this node. 1 will be the default movement cost. Our difficult terrain, like the rubble we just made, will have a higher movement cost. We'll get that in a minute. And obviously our wall will have its passable set to false as well. In the meantime, this is fine. For our terrain, let's green check out of here, and we're going to start by making another parent object. Create object, it's going to be called O_terrain. Doesn't need a sprite, doesn't even need any code, it doesn't need anything. We're completely done with this object. That looks a little silly, right? But we're going to make a couple of other objects that are going to have this object set as its parent. And when we write the code, when we write O_terrain, we'll be referencing everything that has O_terrain set as their parent, all in one fell swoop. So that's why this exists, just to make code easier. Green check out of here. Now we're going to make our couple terrain objects. The objects that are going to have terrain set as their parent. We're going to start by creating O_wall. We're going to have its sprite set to S_wall. And we're going to have its parent set to O_terrain. Now we need a create event. Create event, drag in a block of code, and we're going to do type equals wall. That's it. That's all we need here. Green check out of here. and there, and we're going to make another one. Oh, rubble. I'm sure some of you guys saw that coming. Give it the appropriate sprite, give it the terrain as its parent, another create event, drag in another block of code, type equals rubble. Great. All done. That's all we need to do for these guys. We're going to do all sorts of other silly stuff with them later in other code, but for now, we're done. Now we can open up our test room, and let's just make a room. Let's grab a wall object, and you can hit Control, Shift, and left click, and you can just sort of paint objects like that. So I'm going to make an actual room, and this is where our action's going to be taking place. Our heroes are going to be fighting bad guys in here, eventually. And we'll put a wall here, and we'll put a wall here. Whoa, that was kind of ugly. You can also Control, Shift, right click to sort of paint erase, like all gone. And then Control, Shift, left click, put it back. All right, now these rubble objects, I'm just going to put a few kind of around here. Like maybe this wall was longer and it kind of collapsed in on itself, and maybe part of the ceiling's falling down there, or put a little something here and a little something there. Doesn't have to be too fancy. Just do whatever you want in here. Just try to leave a patch here, because this is where we're going to put our heroes eventually. Other than that, this is good. Now, at some point throughout this video series, all of this will look different. These rubble sprites, they'll look different, and how this room is laid out will look different. That's because I'm re-recording these first few videos because of just terrible sound quality. So when you hit a point that you can notice the differences in how things are laid out, you know you've reached the end of my little re-recording adventure. At any rate, let's close this out. One instance is 0 time. What? Yeah, go ahead and remove. Yeah, if you leave objects outside of rooms, it's not a big deal. Your room's kind of infinite, but, well, let's not get into that for now. At any rate, those are the only objects I wanted, so anything outside of that, they can go ahead and go away. All right, so let's close all this out. Let's head back into ONode. All right, create, blah, 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 down in here. So, what we want is for ONode, when it's created, to detect if there's another object where, like, right where it's at, like the wall or the rubble that we just put in the room. And then we want it to take on that object's relevant properties, then destroy that object, because we don't want it sitting around mucking up memory. So we're going to do this with a switch statement. What a switch statement is a type of logical statement, kind of like an if statement, except a switch pokes at a variable and then it has a set of cases that might run depending on what that variable is equal to. So instead of testing the name of an object that we're colliding with it, like if name or if type equals wall, and then another one for if type equals rubble, we could just have a switch for the type of that object, and then a case for wall and a case for rubble. So you can kind of think of a switch statement as sort of like multiple if statements all built into testing the same variable. So let's try this out. So first we want to if instance position x plus 16, y plus 16. So we want to check right on the node's belly if there's anything there. And we're checking for O terrain. Two parens and a squiggly. So temp terrain equals instance position x plus 16, y plus 16, O terrain. Great. So, if there is anything sitting there, we're going to stuff its ID into this temp terrain variable so we can fiddle with it. Now, comes the switch statement. So, switch temp terrain dot type. So, like I said, this is our multiple if statements, and the thing that we're testing is the type. So our first one is going to be for case wall, and how these work is you case wall, and then a colon, and then you need a break statement when you're done with them. So if its type is equal to wall, we're going to do all of the code in the middle, and then break out of this statement. So type, oh, and we're still running as if the node is what's running this code. So if this temp terrain.type equals wall, we want to take on its property. So type equals wall, sprite index equals swall, passable equals false. I'm going to leave another space in case we decide to come back and fiddle with this later. I like leaving little spaces so I can just dive right in and start coding instead of fiddling with formatting. Now, that's it for it. If it's a wall, that's all we need to do. So now we need another one for rubble. Case rubble, colon, break. Great. All right, so in here we want type equals rubble, obviously. Sprite index equals srubble. Cost equals 2. All right. Now, at the end of all of this, past this squiggly here, and I should give myself a bit more room to work with, so we can keep the code where everybody can see it kind of up in the middle-ish top portion of the screen. But that squiggly that lines up with the switch statement. At the end of this, we want something else. So with temp terrain, instance destroy. And again, this with statement, not a colon, a semicolon. This with statement will run code as if this thing, like this thing, is actually the one running the code. So this will destroy the object we've detected, not the node itself. So just like that, we've taken on the important qualities of the terrain, and then we've killed it, all taken care of. Let's green check all the way out of here, and I'm going to run the game. You guys don't have to. We're going to have an error. So if you're nervous about getting errors, feel free not to run it. I'm going to run it. Again, I'm planning on an error so I can explain some important stuff about how GameMaker works. So, run it. Okay, so we've got an error. Everything looked right? I mean, everything looks like it should run right, but for whatever reason, it can't seem to access the type of the terrain we've created. So, this is a data access error. Whatever node that this is that's trying to access this terrain, it can't access the type variable of the terrain piece it's detecting. So what's wrong? Well, this is sort of an odd corner case, which is why I figured I'd demonstrate it. So all of these objects are in the room, clearly, right? Let's abort out of here and let's look at our room, right? So clearly, I put all these walls and this rubble there, but we're getting this error after their collisions were detected too. So if we're detecting collision, obviously it's there. Why doesn't it have its type variable worked out, right? What's the problem? Well, so they're all there, and they're obviously technically created. However, they haven't actually done their create events yet. See, how GameMaker works is that all of these objects have events which occur in an order. For instance, each full game step is a begin step, a step, collision events, an end step, and a draw event. And there's other minor events kind of peppered around in there. All of this appears to run simultaneously, but it doesn't. Computers don't work like that. They appear to because they run so fast, but really it's just a great big line of one thing happening at a time. What GameMaker essentially does is call out to all the objects like, hey, everybody with a begin step event, line up, and we're going to go through your code one by one. And then it does, everybody with the step event, line up, let's go. And they line up in order of their instance number, which is the order they've been created in. So here, we've got all of these walls, right? We've got all of this rubble. We've got our OGame object up here in the top left corner, right? But the OGame's create event, it's running first because it was created first. So all of our nodes are being created, which is here's where we get into our hiccup, right? So our OGame event fills this whole room with nodes. But because it requires them to run as a part of its creation event, they're going before all of these objects have their create events. So it's detecting this wall here, but that wall hasn't had a chance to run its create event and declare its type. So that's a problem for us. But it isn't a big problem because, see, we obviously know how this works. I just explained it. We can work around it. And the bright side is the workaround is pretty easy. Our OGame object will need a couple different steps to progress through the game anyway, and so we'll just handle all of this stuff inside of what it states. So, green check out of here. We're going to go back into our node object. And we're going to select all of that mess, and we're going to hit Control X, or whatever cut is, if your keyboard or layout or whatever is different. But that will copy all of that information into the clipboard for us to paste later on. So don't worry about that. screen check out of here, and we're going to go into our OGame object, and we're going to create a step event. Drag in a block of code. Drag in a block of code. There we go. Okay, so now in this step event, we're going to type the following. With onode. All right, now we're going to paste all of our code in here. Bloop. Like that. So now, after all the create events, in the step event, this will happen. Now, obviously, we don't want this to run every single step. That would be silly, right? So, well, never mind. Let's talk about this with statement again. We've already done a few of these, and I just want to, like, this with statement's special, though. We're not doing with a specific instance, right? We're doing with onode. So what this code is actually going to do is it's going to say, hey, every single node, do all of this. And again, they're going to do it in the order of their, however they're created. So it'll be like, hey, you, instance ID 100047, you're a node, so do this. And then it's going to be every other node. So doing a with statement like this is a very powerful piece of code, and it's going to do quite a bit. I mean, like I said, it's going to grab every single node and be like, do this. And you can do a lot of really cool things with this, like, hey, every instance of fire, burn anyone in the square that you're in for 3 points of damage. Or, hey, all actors, put your ID in this list so that OGame has a turn order. Cortana, leave me alone. Or here, all you nodes line up, and if there's a terrain bit under you, do this stuff. Now again, we don't want this to run every step. So we need to put a qualifier around this whole thing. And what this is going to be is the beginning of our game controller's switch statement. So, it's also going to be our first sort of state machine of this coding extravaganza we're embarking on. So, switch state, and we're going to have to obviously add a state variable later. And we're going to do case initializing, colon, and then we want all of this stuff to happen. So, if our state is initializing, we're going to do all of this mess. Oh, and obviously at the very end, we need a squiggly bracket to cap off our switch statement. And then down at the bottom of this, right, we still don't want this to run more than once. We need to change our state to something else. So state equals ready, which doesn't have to do anything. It could just be nothing. And then when we get to the state and it goes oh, it's ready. Well, I don't have a case for ready. It'll just do nothing, and that's fine too. So break. So there we go. We have our first state machine, and it doesn't really do much, and it's not that complicated. It'll do more later, don't worry. So now, obviously, we need to give a state to this game controller object. So let's green check out of here, and let's go into the create event. We can go into the create event. There we go. So right at the top, right up here, right after we make our global variable. Well, you know what? Dag with it. Right before we make our global variable, we'll get our game controller's stuff taken care of before anybody else. We do state equals initializing. Boop. Okay, so now it states initializing. What it's going to do is it's going to go in here and be like, okay, initializing. It'll do all of this after everything's been created, after everything done its create event, and then it'll go to ready, and then we don't have to worry about it ever again. Great. So now, to make sure that everything's working out all right, we're going to go into our cursor draw event, and we're going to add some more debug information. We're going to be doing a lot of this, by the way. So, if hover node equals no one, and we've got all of this junk set up in here, right? We're going to do some more. So, temp text, after we're done displaying all that other stuff, we're going to do temp text equals hover node dot type. Boop. And then if hover node dot passable equals, we'll just leave it at that. If hover node dot passable, temp text plus equals space passable equals true plus space cost equals plus string hover node dot cost. Great. So we'll display all of this stuff. And then we'll also display if it's passable, hey, it's passable equals true, and it's cost. Great. So, another big black rectangle. Let's get up here so it's easy to see all the stuff that I'm typing now. So draw set color C underscore black loop. Draw rectangle. We want this to be right below the first one, so or right below where we do the name. So we want to be top left of the screen, so 0, about 20, that'll leave a little bit of a space. String width, temp text, 20 plus string height, temp text, obviously false. We want a full rectangle, not an outline, and I've made an error. Oh, rectangle, not rectangle. I can't even pronounce whatever that was. Draw set color, back to white, C underscore white, and then draw text, 0, 20, temp text. Alright, so that's just another simple black box to give us a bit more information. So let's try running the game now, and we'll mouse around and make sure that all of our information is correct. Alright, so we can see all the terrain, that's great. Although the normal nodes are... what is going on there? Why is that not drawing properly? Why are you being a jerk? What is up with that? Hold on, let's see what my error is there, because that's a problem. I mean, it's obviously drawing it right, but it's not doing the rectangle correctly. I must have made an error. Let's take a look at that. And if I made an error, you poor folks following at home, you 20 plus string height. A lot of you cats at home are probably pretty sharp and you caught that, but you know, everybody makes mistakes. That's part of coding. No big deal. It's even not a big deal if it's an infinite loop. Just Control-Alt-Delete and kill the process, and you can go right on back. Everybody makes mistakes. So, all of these nodes, they're passable. This is passable equals true, cost equals 1. Great. That's not passable, so it just says wall. Also great. Let's check our rubble. Alright, cool. Passable, true, cost equals 2. Perfect. Alright, now let's pick Sandy up, and let's put her on some rubble. That works fine. Let's pick Danny up. We'll try to put him on a wall. No dice. Awesome. Now we're still creating our couple of characters in the game's create event, and that is some blunt force ugly coding. So let's do to Danny and Sandy what we've done with our terrain. Let's go to our game's controller again. Let's hit into here. Let's go into its step event. Oh, well actually first, let's do the important part. Let's go to our create event, and let's just delete all this junk at the bottom. We don't need this anymore. Where we create Sandy and Danny the old way, boop, gone. Don't need it, gone. Alright. Let's go back up at the top, and when we create our nodes, we finally need to let them know where they're at in the world. So map xxyy dot grid x equals xx. Map xxyy dot grid y equals yy. So now they'll know where they're at. Great. Now let's hit that step event, and let's add some more little bits to the bottom. Okay. Right after temp terrain instance destroy. Right after here. All that. With oh no, we're still in the with oh node, but right after the terrain stuff. We're gonna do. Let's give myself a bit more breathing room here too, huh? Alright, so we're gonna do if instance position x plus 16, y plus 16, o actor, 2 parens and a squiggly, occupant equals instance position x plus 16, y plus 16, o actor, great, occupant dot grid x equals grid x, occupant dot grid y equals grid y. Great. So if we detect an actor standing at that position, we store them to our occupant variable, and then we set their grid x and grid y equal to the node's grid x and grid y. So now the nodes know where they're at in the map, and now all the actors will know where they're at the map. Everything's great. So now there's 2 ways we can handle going about doing this stuff. Let's screen check out of here. I'm going to go ahead and demonstrate both. The first is we can go into our room, go into objects, right? And we grab our hero, and we can just place them in the room like that. And we can right click, and we'll, where is it? Creation code. We can do name equals Sandy. And then in this one, we can right-click, creation code, name equals Danny. And so now, when they're detected, they'll have their names and they'll have whatever. In fact, let's go ahead and run it and make sure it's working. Should be faster to load up the second time. Here we go. So now that's obviously Sandy. That's obviously Danny. It's working great. Awesome. And we can still sort of move. Great. See that node's empty. This one still has Sandy in it. Same thing for Danny. Everything's working great. So that means all the data is working right. All of the instance IDs are being passed around proper. Excellent. The problem with this is that you'd have to go into each individual room and do creation code for each and every one of your heroes. And that's fine. And it would work for some games if that's what you want to do. But I think it's tedious as heck. I don't want to do that. So let's kill this game, and let's go back to the drawing board on how we're going to do that one. Let's go ahead and just delete both of these folks from here. Delete. There you go. Okay, so let's rename our hero. Oops, let's rename her to Sandy. Rename to O Sandy. Enter. And we'll go into here, add a create event, drag in a block of code, and we're going to do name equals Sandy. Alright, green check out of there and there. We're going to duplicate this object. Should duplicate, go. Okay, it goes, oh, Danny. I sometimes find that yelling at inanimate objects really helps. Not yelling. Let's not get a bit. You got to tell him who's boss. Alright, especially when you're coding. Jeez. Get into here, we'll change his name to Danny. Great. Bloop, bloop. Now we're going to go into our room, and we're going to place Sandy here. And we're going to place Danny here. Now, some might think this is especially tedious. Well, it is kind of tedious, because we've got the same sprite for each of them, so you have to make sure, okay, that's Sandy, that's Danny. And it shows down here, by the way, when I mouse over, you can see that there. But eventually, our heroes are going to have a bunch of statistics. Like, Danny's going to have a strength of 16 and a dexterity of 8 and whatever. And so if we did it the other way, we'd have to put all their statistics in every time too. And that's just a huge pain. So this way I think is much better for how we're getting things to go. And it would be much easier to see what you're doing if you're in your own game and you've got your own sprites and everything else. But at any rate, let's green check out of here and let's go into our run our game and make sure everything's working fine. Alright, so that's definitely Sandy. Clicker. That's Sandy selected down here. Let's move her there. Now that's Sandy. Great. And that's not Sandy. Awesome. Same thing for Danny. That's Danny. We still got Danny selected. There we go. Okay. So, that wraps up this video. Everything's working great. The next step is to give Sandy and Danny movement ranges, and that means pathfinding. Pathfinding means like a half-assed ASAR and all sorts of other nonsense. So far, I've been trying to cut everything into the smallest parts possible to make this easy for me to teach, but you really can't do that with pathfinding. You either have all of it and it works, or you don't, and it doesn't. So that's not going to be like oh, we did a little thing, let's see it work. That's going to be like, we're going to be coding for like a long time straight, and then that's it. So we're about to all figuratively bite off more than we can chew, but we're going to chew it. So next video, I'm going to try to explain how our pathfinding script will work, and then the video after that, we're actually going to go through coding it. I'm going to try to make it as easy to understand as possible, and I'm going to provide links to some articles and sources that I use to understand all of this in case I don't explain things adequately. So, for those of you who've fiddled with things like A-star or movement on a grid before, feel free to skip the next video if you feel you have a good grasp on the subject. Then we can get straight to the code. I really enjoyed making this tutorial so far. If you're enjoying watching it, be sure to like, subscribe, or leave a comment. Thanks for watching, everybody. I'll see you next time.